All right, this lesson is RI 6.1, making inferences from informational text. Don't confuse it with RL 6.1. That one is about stories versus nonfiction. Let's start with the words that we need to know. Our first two words to review are the words explicit and imply. These are kind of opposite in a way. When something is stated explicitly, it is stated clearly or directly. Whereas if something is implied, or if you imply at something, you are hinting at it. So I can imply that there's going to be a surprise party, but I can say explicitly that we're going to go to the movies tomorrow. Our next word is the most essential word for today's lesson, and that is the word inference. An inference is when you draw a logical conclusion using information. So we're going to write that. Draw a logical okay, using evidence. And so obviously we need to know what evidence is. Evidence is our proof. So proof that shows something is true. Go ahead and make sure you have all of these definitions. All right, our strategy to help with making inferences is actually an equation. When we make inferences, we take, first of all, clues from the text. We add that to our own prior knowledge, things we already know, and that's how we are able to make an inference. This is what we'll be practicing with today in today's practice. Make sure you have that equation written. Let's go ahead and read our article. This is called Eating and Your Brain. As we read this, we're looking for information that will help us make inferences using our prior knowledge. When you are full from dinner, do you eat a tempting dessert if someone offers you one? At the International Conference on Obesity in Stockholm, researchers presented a study that might help explain why some people would say no and others would say yes. The body has built-in fullness signals, most of which start in the digestive tract. When the stomach and intestines are full, chemical messengers are released. Those signals make their way to the brain and signal the body to stop eating. Yet some people will eat tempting foods even if they are full. At Columbia University in New York, researchers showed pictures of sweet, high-fat foods such as cake, pies, or French fries to 20 subjects. Of these subjects, 10 were obese and 10 were not. The researchers used MRI scans to monitor their brains. When obese people see the high-calorie foods, brain areas involved with pleasure are activated, making it hard to resist the food. The sight of lower-calorie foods, such as cabbage and zucchini, did not trigger the same response. The brains of subjects with normal weights responded strongly only when the subjects were hungry. Before we go on and make our inferences, we're going to pause for our scavenger hunt find of the day. You are all being Smarties, so the scavenger hunt find of the day is a pack of Smarties. All right, let's go ahead and do our practice. Look at the chart. You'll see that we have space for our evidence, our prior knowledge, and an inference that we can make. I'll provide the evidence and give some examples of prior knowledge so that we can make inferences together. All right, the first evidence that I found was on the first page. The passage talked about how when the stomach is full, chemical messages are released to our brain and they tell us to stop eating. I'm going to combine this with my own experience that has to do with this. I know, for example, when I eat really fast, I can be suddenly hit with a sense of fullness. So I'm eating. I'm trying to eat as fast as I can because my food is so delicious. And then all of a sudden I feel so full, I think I'm going to explode. So the inference that I'm going to make based on this is that maybe it takes a little bit of time for the stomach to realize that it's full before those brain signals are released. I'm combining the evidence with my prior knowledge to make the inference. So I'll say it takes a little time for the signal to reach the brain. Now, I'm going to make and encourage you to make another inference using another piece of evidence we found on this side. So I'm going to say that in this study, it said that when obese people saw high-calorie foods, they felt happy, and they felt happy. I'll just leave it at that. So when obese people saw high-calorie foods, they felt happy. And I think about this, and even people who I know that aren't obese, and myself included, when I see food that looks delicious, like French fries or ice cream, those are foods that make me feel really happy, and it can be really hard to resist those foods. So from my own knowledge, I know that I will eat delicious, and I'm not talking vegetables, food, even when I'm not hungry. Now, the inference I can make by combining these two things is that if we feel happy when we see these high-calorie, not as healthy foods, and we eat them even when we're not hungry, then it probably means that our brain sensor doesn't overpower our desire for these foods. Like the brain sensor isn't strong enough. That chemical isn't strong enough to tell us to not eat it. So I'll put as my inference, the chemical signal isn't strong enough to resist the high-calorie food. All right. If you feel pretty good about being able to make an inference, you're ready to prove your understanding. You're going to read this passage about rats and junk food, very similar and a very interesting study, and then answer these two multiple choice questions about inferences. Go ahead and complete your exit slip, your proving behavior. Your goal is to get both of these multiple choice questions correct. Thanks for participating in this lesson.